So in this video series, we're going to be looking at solving trig equations using identities for exact values from 0 to 2 pi. You can print the foldable and follow along if you would like, or you can take notes on regular paper. It's up to you. And we're going to be using a TI-84 plus graphing calculator to check our answers. You can use whatever calculator that you have that lets you switch between degrees and radians and store values for a variable. So let's begin with example 1. And when we look at this trig equation, right away we're reminded whenever we see pi over 2 minus x of the cofunction identities. And remember, those cofunction identities are horizontals across the trig identity hexagon. So cosine is the cofunction of sine, cotangent is the cofunction of tangent, cosecant is the cofunction of secant. And those cofunction relationships exist because of complementary angles. And we have another video that you can go back and look at if you want more information about where those came from. But for now, we'll just recall that whenever we see a sine of pi over 2 minus x, we're going to use the cofunction to get its equivalent, which is cosine. So this cofunction identity will give us a cosine of x now in the numerator. Okay, then in the denominator, the cosine of pi over 2 minus x, that's the cofunction relationship going the opposite direction. And since the cofunction of cosine is sine, we're going to swap out sine x in the denominator using the cofunction identity. And that is still equal to the square root of 3. Okay, then back to the trig hexagon for remembering our fundamental identities. If you recall that the quotient identities are consecutive vertices, either clockwise or counterclockwise around the hexagon. So if I look for cosine, which is here, and sine is consecutive, right? Those are two consecutive vertices. Then going this direction, cotangent is equal to cosine divided by sine, which is what we have, cosine divided by sine. So we're going to substitute in cotangent now for that ratio cosine over sine using a quotient identity to say that the cotangent of x is equal to the square root of 3. Okay, then last but not least, we remember that on the diagonals of our trig identity hexagon, we see that the reciprocals are across those diagonals. So the reciprocal of cotangent, right, that's pointing to tangent. The reciprocal of cosine is secant. The reciprocal of sine is cosecant, right? Those form the diagonals. And since we're looking for the cotangent of x, we follow that across and find that its reciprocal is tangent. So since cotangent of x is the same as 1 over the tangent of x, now when I cross multiply, I'll have square root of 3 tangent of x equals 1, and I'll divide both sides by the square root of 3, and tangent of x is equal to, we're going to rationalize this denominator here real quickly, and tangent of x is equal to the square root of 3 over 3. Okay, so now we're back to just a real basic one-step trig equation that we learned how to do in our previous unit. So we want to look to get this x by itself, we want to look to take the inverse of both sides. So x is equal to the arctangent, or the inverse of tangent, and that's square root of 3 over 3. So we're looking for the angle on the unit circle that has a tangent of positive root 3 over 3. And for those who remember our reference angles from the unit circle, here's a picture of the first quadrant. And tangent is the ratio of the sine over the cosine. So the tangent at 45 degrees is equal to 1. Okay, then the tangent at pi over 6, when we take 1/2 divided by root 3 over 2, we get 1 over root 3, which rationalizes to be root 3 over 3. For the tangent at pi over 3, root 3 over 2 divided by 1/2 is just square root of 3. Then 0 divided by 1 at 0 is 0, and 1 divided by 0 makes the tangent of pi over 2 undefined. So these are the tangent values in the first quadrant where everything is positive. So we can see in quadrant 1 we've got a solution here at pi over 6. So x equals pi over 6 is going to be one of the solutions that we want to check. But we also remember that this is just the first quadrant, and there's another place on the circle, another quadrant, where tangent is positive. So that acronym, all students take calculus, that reminds us that everything is positive in quadrant 1, all 6 trig functions. In quadrant 2, the sine and its reciprocal cosecant are positive. Everything else is negative. In quadrant 3, the t reminds us that tangent and its reciprocal cotangent, those are positive in quadrant 3. And then the c in all students take calculus, that c means that cosine and its reciprocal secant are positive in quadrant 4. We already found the quadrant 1 answer, pi over 6. Now we can see that in quadrant 3, there's going to be another solution. So we need to find a reference angle for quadrant 3. So if this is our quadrant 1 reference at pi over 6, and this is obviously not to scale, and half of the circle is 6 pi over 6, then we need to get into the third quadrant by adding another pi over 6, which makes our other solution at 7 pi over 6. Okay, so now to check those solutions in the calculator, we're going to first check that we are in radian mode. Oops, guess can't see the calculator screen there. So we first check that we're in radian mode, and we are. Okay, and then we're going to go back to the home screen, and we're going to store pi over 6 as the value of x. Okay, and it doesn't matter that we see this decimal approximation on the screen. The calculator knows that we're interested in storing that exact value for pi over 6. Now we're going to go ahead and put in the numerator our original problem, which was the sine of pi over 2 minus x. Then in the denominator, we're going to put, from our original equation, the cosine of pi over 2 minus x. And then to get the equals, we press second math, where we see the test menu up above there, and number 1 is the equals button. And then we want to show if that equals square root of 3. Okay, so when you do this in the graphing calculator, at least in the TI-84+, when you put that equals in there, that's a test, and so you're asking the calculator, is this a true statement or not? Is it true that if I substitute pi over 6 in for x in this equation, that it returns a true statement? If the calculator tells you 1 when you press enter, then it was true, and if it returns a 0, then it's false, and we've got a mistake. So here we get back a 1, and so we know that that first solution checks. Okay, now I'm going to store 7 pi over 6 as my new value for x. And I don't want to have to retype that whole equation again, so I'm just going to arrow back up to it and press enter, and then it's retyped now. And the calculator knows that I have a new value stored for x. So when I press enter, now it's shown us 1 again, which means that 7 pi over 6 also checks.